Hello everyone and welcome to our video lesson today on scatterplots. This is 15.1. With scatterplots we have what's called a explanatory and response variable. The explanatory variable in a simpler way is the cause of a relationship. So here's the explanatory variable. And then whatever is affected by it, the effect, is called the response variable. So we're just going to practice some situations and see which one is the explanatory variable and which one is the response variable, or what's the cause and then what's the effect. Sometimes there is no cause and effect. In that case, we would just write there is no association, or NA. So let's just think for a moment. The length of a person's foot and their shoe size. Is there a relationship between those two variables? I would say that there is. It says here, let's underline the cause once and the effect twice. So the person's foot is the cause, and an effect of their person's foot is their shoe size. So I think everyone would agree that the person's foot is the biggest determinant of the shoe size that they would then pick. Number 2, the outdoor temperature and the amount of gas consumed. Generally, the warmer it is, the better gas mileage your vehicle gets, so the less gas is consumed, and the colder it is outside, the more gas your car has to consume for it to work efficiently. So the outdoor temperature is the effect, and the amount of gas the outdoor temperature is the cause, and the amount of gas consumed is the effect. The outdoor temperature has a big cause on how much gas is consumed, so that would be the effect. Number 3, the annual tuition at college and the average ACT/SAT score for students at that college. This might be an interesting relationship to study a little bit more. Sometimes the private colleges do have a higher annual tuition, and oftentimes those private colleges maybe require a higher ACT/SAT score. But you can make a case either way. There are some very expensive schools that maybe you don't need a great ACT/SAT score to get into. So I would say this one, there's no association, or it would be interesting to at least explore that association and see. But nothing that really is direct that comes out at you. Same thing with here for number 4, the hours of sleep per day a person gets and the hours per day the person spends studying. Just because you get a lot of sleep doesn't mean that you spend a little time studying, or just because you get a lot of sleep doesn't mean you spend a lot of time studying. So there really isn't too much association between these two variables. We would write NA for this one as well. Number 5, the age of a car in years and the price of a car in thousands of dollars. Well, generally the older a car gets, the less money it's worth. So the age of the car would be our explanatory variable, or our cause, and the price of that car is going to be the response variable. The older it gets, the less it's worth. Unless it gets to an antique, now the older the car is, the more valuable it becomes once it gets to be old enough where it's like a collector's item kind of a thing. So there's just a little bit of practice on identifying the explanatory variable and the response variable. So when we describe a scatter plot, we always describe it what's called using the DOFs. The direction, outliers, form, and strength is what this DOFs stands for. So the direction, when we describe a scatter plot, it's either going to be positive or negative. So if it goes up and to the right, it's positive. If it goes down and to the right, it's negative. Just like slope. A positive slope goes up and to the right, a negative slope goes down and to the right. The outliers, you guys know what this is. It's data that is way off compared to the rest. The form, we're either going to say it's linear or nonlinear. So once again, you guys know what a line looks like. Y equals mx plus b. And if it's nonlinear, it could be formed like a parabola. It could be more of like an exponential graph. We're either going to call it linear or nonlinear for the form. And then the strength. The strength is, we would say it's strong if the points really closely resemble a line. It's weak if the points are really scattered. So here would be like a scatter plot. Scatter plots are generally always in the first quadrant. So here's the x-axis, here's the y-axis. If there was a relationship like this, bunch of data entries, this would be a strong linear relationship that very much resembles a line. The further apart these points get, now this is weaker. It's still a linear relationship, but it's just a little bit weaker. And as the points get even more and more and more spread out, the weaker and weaker and weaker it becomes. So if all the points really close resemble a line, it's a strong relationship. It's a weak relationship if the points are very spread out and scattered. Okay, so when we have two variables, we've done a bunch of different graphs. We've done histograms, we've done stem plots, we've done box plots, a bunch of different things. Those are generally only used when we have one variable. Scatter plots is when we have two variables, like a cause and effect, a explanatory variable and response variable. We always put the explanatory variable, or the cause, on the x-axis. So then the response variable then would go on the y-axis. Okay, so what we're going to do here, I skipped a slide. I apologize, class. Let's go back to this one. So for each and every one of these, what we're going to do here is we're going to describe each scatter plot using the DOFs. Okay? So here we go, our direction here. If we take a look at this, it looks like our direction is kind of going up and to the right. So our direction then would be positive. Next, we would say our outliers. Well, it's kind of tough to say on this one, I guess. Data that's way off compared to the rest. You could probably make an argument for a couple. This one maybe you could think is an outlier. Maybe one or two of these over here. Possibly this one. Data that is, way off from that line would be considered an outlier. It might be difficult to say with confidence because they are somewhat closer to some other data entries around it. So on this one, we're going to say that there are no outliers. There are none. It'll be obvious to you on a test if there are outliers. So there are no outliers in this one. Instead of saying none, I think I'll just write no outliers. Okay, the form. The form is either linear or non-linear. And I think you guys would agree with me that this one is linear. It generally looks like it forms a line. The data entries for the scatter plot generally form a line. And then the strength, you'll recognize this more as the chapter goes on because we'll see a lot of scatter plots. This is a pretty strong relationship. Those points all generally resemble a line, so it's pretty strong. Okay, so on a test, I would be looking for more of a sentence. I would look for something like, there is a strong, positive, linear relationship between the duration in minutes and the interval in minutes for this certain relationship. And there are no there's no obvious outliers. Something like that. You'd have to write a sentence that goes along with that. Okay? Taking a look at this next one, it can be kind of tricky because this one is not linear. This one is more of like an exponential kind of graph where it has a curve to it. So this one, we wouldn't say it's linear. We would say it is non-linear. However, the relationship is still pretty strong. I would say it very much resembles a curve. So we would say it's a strong relationship. Let's see, so we've done the direction we wouldn't necessarily have with this one. The outliers, our book for this example wants us to see that these three right here are outliers. I would say especially Botswana and Gabon are very obvious outliers. Namibia could maybe be argued either way, but let's just put an out arrow to this, and these ones would be considered outliers. Okay, let's take a look here at this next one. This next one can kind of trick people up a little bit, especially when it talks about the strength of this relationship. I would say that it's clearly linear. All these points generally resemble a line. So this is linear data. We would say that it would be negative for the direction. It's a negative direction. It goes down and to the right. How about the strength of this relationship? Some people think it's weak because the points are very spread out. However, this is a very, very, very strong relationship. The reason why it's strong is it doesn't matter how spread out the points are. The strength is how far apart they are from making a line. And so if there was like points way over here, now they're far away from that line that kind of generally represents all the points. Whereas all of these points are very close to this green line that I drew up here. So this very much resembles a line. This is a very strong form. Linear, negative, and it is strong. There are no outliers. All of those are really close to that line that I drew up there. So this is no outliers. And then our last one, this would be really tough to say. If you looked at this, one person could maybe make the argument that this looks linear and it looks positive. And another person could be equally correct and say, I don't think so. I think it is negative and it goes this way. Something like that. Another person can make the argument, I think that it's linear and the best linear data is something like that. Well, if that's the case, class, these points are so spread out and all over the place, there is no relationship. We'll just say there is no association. And then you don't even need to describe the DOFs at all. The direction, outliers, form, strength, there just is no association. Okay, so now moving on with this one. When we write a scatter plot or make a scatter plot, that's always going to be used when we have two variables. We put the cos or the explanatory variable on the x-axis, and then on the y-axis we put the response variable. So here's an example. Low fat and low carb. Over the last few years, many people have gone on low carb diets while others have tried low fat diets. Here are data on 9 different types of sandwiches or hamburgers at McDonald's. And maybe you've had some of those before. So you can see them in the charts. What we're going to do here is we're going to do the state, plan, do, conclude. State, plan, do, conclude, and it's kind of abbreviated right here. State, plan, do, conclude. It's a very common statistics kind of a problem. The first thing we're going to do is we're going to state what we want to accomplish. So we want to see what is the relationship between the amount of carbs and the amount of fat in McDonald's hamburgers. We want to see, is there a relationship between those two? Okay, so please write that down in your notes. Next thing we're going to do is we're going to make a plan. Making a plan oftentimes, especially in this class, consists of making a scatter plot. So we're going to make a scatter plot. We're going to define what the explanatory and response variable is. We'll make a scatter plot with carbs as the explanatory variable and fat as the response variable. Sometimes that'll be very obvious to you because the explanatory variable is always the cause and the response variable is the effect. In this case, though, these roles could be reversed because one doesn't cause an effect in the other. So on this one, it could be reversed. And then after that, we're going to describe any observed associations. So why don't you guys pause the video, please, and put carbs as your x-axis and put fat as your y-axis. And why don't you guys put these in your graph and make a scatter plot. So please do that right now. After you've done that, you should have a graph that looks something like this. We always title our graph. So we're going to title our graph as something like McDonald's sandwiches or McDonald's burgers. And we always label our x and y axis. So our x-axis is carbs in grams, and our y-axis is fat in grams. So we have a scatter plot that looks something like this. So now let's do the DOFs. That's the do part. So we're going to define the direction, outliers, form, strength. So once again, I don't just want you to tell me, I don't want to just see the words, it is strong for the strength, and it is positive for the direction, and it is linear for the form. Just don't say those words. I want you to write a sentence. This scatter plot shows a fairly strong, positive linear association between the x and y variables, carbs and fat. There are no obvious outliers. If you were to be picky and you were to really try to decipher if there is one, maybe you could pick the double quarter pounder with cheese as an outlier. Okay? So something like that, a sentence, kind of tying in the dots is something that I'm looking for under the do part. And then the last part is the conclude. So it's kind of like our summary, the total observation as the amount of carbs in a McDonald's sandwich increases, the amount of fat increases linearly. So that's a little introduction on scatter plots. We'll be doing much more of that as time goes on in this chapter.